So today we are going to talk about permutations, which is actually a form of the counting principle. We're going to talk about combinations. What? There's repetitions. Yep. Do you remember it? Well, at least that's a start. And we are going to talk about factorials, which is where we're going to start at. On your calculator, if you have it out and looking at it, or any calculator, your Chromebook probably has it, factorial is a math symbol that's an exclamation point. We are going to be using factorials in the formulas that we're going to use for permutations, combinations, repetitions. Okay? A factorial means if I had 3 factorial, it actually means starting at 3, it is 3 times 2 times 1. Some calculators do, some don't. So if I had 5 factorial, it would be the same as 5 times 4 times 3 times 2 times 1.
The PRV button.
Did you find one that has factorial? On different calculators it is differently, so if I took 3 times 2 times 1, that's easy to find, that's a 6. But as you can see, even with small numbers, these things get big quite quickly.
Yes.
5 times 4 is 20, times 3 is 60, times 2 would be 120. So let's try 8 factorial.
40,300.
Which would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you said it was 40,000?
320.
Okay? So it makes sense what we're doing with factorials and how to find it. Okay? Because it will become extremely important when we get into the formulas for permutations and combinations, and essential for repetitions. Permutations. Where do permutations come from? Let's say there's a nice little formula that goes along with it, but let's say we have 3 officers that we have to select from 14 people. Well, if I'm selecting 3 officers, can the same person be in 2 offices? No. Okay? So the easiest way, sometimes with a simple permutation, is if I have 3 officers, I have 3 spaces that need to be filled. When I first start this, if I have those 3 spaces that need to be filled, how many different people can I put into this office?
14.
A selection of 14 people, right? Okay? If I've used one of those people for this office, how many can be put here? 13. Right? And how many can be put here then? 12. Does that make sense? And how can I find out how many total different permutations or counts can I make? I multiply them together. So if I had 14 times 13 times 12, 2,100. Okay? Does that make sense? Or not? Okay? That means let's take something a little more relevant to you that sometimes you wonder why you may not be in the starting lineup for a basketball game. There are 5 people that can start, right? Do you agree? And some people say you need a different starting lineup for every game. Well, let's take boys. How many boys were there this year in basketball? 16 boys? Right? How many boys could I select for this one?
16.
I could choose from 16, couldn't I? From here I'd have 15 left?
Yep.
14?
Yep.
13? 12? How many different starting lineups could you come up with?
500,000 to 24.
500,000. 524,000. Do you think you play that many games to come up with that many different starting lineups? Kind of impossible, isn't it? Huh?
Even put them in one. Probably not.
Yeah, probably there.
Someone's got a really good one.
Permutation formula. A permutation means that order is a must. In other words, the order in which you pick people is very important. Okay? As to who's first, who's second, who's third. Just like if we were picking those officers, it made a difference, didn't it? Okay, so that means that order is prevalent on that. Formula that looks like permutation. Looks like this. N, P, R equals N factorial over N minus R factorial. What's the N's, the R's, and everything? We're going to discuss that, but this is the formula for finding a permutation. Remember before when we said we had 14 people, 3 offices, right? That we wanted to select? And we came up with 14 times 15 times, or 14 times 13 times 12 when we figured that. Actually, we will do the same thing here. For a simple permutation, sometimes drawing the boxes are easier to do than going through this formula. But the N is the number of people that you have to choose from, or the number of items that you have to choose from. How many are you going to use is the R. And the P means permutation. Okay? So if I was to write this problem out, if I had 14 people and I was going to use 3 of them, then I would have 14 P R equals 14 factorial over 14 minus 3 factorial.
2,184.
Okay?
Why isn't the R on the outside 3? Like the
Well,
14
this should be 3. Sorry. Means 14 items taken 3 at a time.
Okay.
Now, if I looked at this particular formula and started to simplify it, bless you, this is going to be extremely large if I put 14 factorial in the calculator, wouldn't you agree? It's gigantuan. And this is gigantuan, but not as gigantuan as what this is. But watch this. 14 times 13 times 12 times 11 factorial.
We can't see.
Over 11 factorial. Isn't this an expression for 14 factorial? I could continue to write it out as 11, 10, 9, 8, 7, correct? Wouldn't this one be written as 11, 10, 9, 8, 7, etc.? Won't this all cancel this? So that gives you your 14 times 13 times 12, which somebody said was 2,184. Right? Okay? Let's do this one. You got a license plate. We're not going to do this one by a formula. It has six places. Okay? I can use letters here for all of these except O. For all three of these. Okay? Why not an O? Because an O generally looks like a 0. Okay? Over here for the digits, I can use 10 digits here, 10 digits here, 9 here, which means I have to use 1 through 9 here. Here can be 0 through 9. Does that make sense? So how many letters can I put here?
46. 45.
25.
24. 23.
I can put 25 here. I can put 25 here, can't I? Right? I can repeat, I just can't use 0 or O. So can I use the same letters again? Same letters again. Same way over here with the digits. I could have 9 digits here, couldn't I? Except I can't use the 0. But here I can have a 10 and a 10. So how many different license plates can the prisoner make? 14,062,000. 500? A lot of license plates, right?
Yes.
Okay. Would it change if I said you can't repeat anything?
Oh yeah, just go 25, or 25, 24, 23, 9.
Okay, if I can't repeat, okay. What about the digits? How many could I put here? 9, right? How many can I put here?
9.
Up to 9, providing that this one isn't repeated, right? How many here? 8. So how many license plates could I make then?
8,942,500.
8,942,400. Big difference by just saying I can't repeat letters and numbers, right? Really cuts it down. Okay. So if I wrote a problem that stated this, can I find that by counting principle permutation? In other words, I have 18 items taken 4 at a time. There's actually two ways you can do it. If we wanted to use the formula, what would the formula look like?
18 factorial over minus 4 factorial.
Right? Which means this would be 18 factorial over 14 factorial. Because the 14 factorials would cancel each other, wouldn't they? Right? So how many different selections would I have? 72,000. 73,400. 40.
Oh, you did 18 factorial, not 18.
How did you get that though?
I typed in 18 and then I pressed the NPR and then I typed in 4.
Where's that at?
Okay? Whatever the number was, because whoever was telling me kind of trailed off into Never Never Land.
Then you typed in what?
Did you type in